In 4.3, the goal is to graph linear equations using intercepts. Your x-intercept is the x-coordinate of a point where a graph crosses the x-axis. The y-intercept is the y-coordinate of a point where a graph crosses the y-axis. In example 1, they want you to find the intercepts of the graph of an equation. Here you've got 8x minus 2y is equal to 32. So to solve for your x-intercept first, you can substitute 0 in for y. And then you can solve for x. After you plug in the value of 0 in for y, that gets rid of the y term. So now you have one-step equation, 8x is equal to 32. You can divide both sides by 8. And now the value of x is equal to 32 divided by 8, which in this case is going to be 4. So the x-intercept is the point 40, and then to get the y-intercept, substitute 0 in for x, and solve for y. After you plug in 0 in for x, you now get the one-step equation, negative 2y is equal to 32, and now you can divide both sides by negative 2. Y is now by itself, so now you have 32 divided by negative 2, which is negative 16. So in this case, the y-intercept is negative 16, and the x-intercept is 4. Moving on to the checkpoint, here they want you to find the x-intercept and the y-intercept of the graph of the equation. Again, to solve for the y-intercept, set x equal to 0, solve for y. To find the x-intercept, set y equal to 0 and solve for x. So doing that with number 1, plug in 0 for x and solve for y. Divide both sides by 3. So the value of y is equal to 6. So in this case, your y-intercept is the point 0.06. To solve for the x-intercept, plug 0 in for y, solve for x, divide both sides by 2. And if you take 18 divided by 2, the value of x is equal to 9. So your x-intercept is the point 90. Moving on to number 2, to solve for the y-intercept, set x equal to 0, solve for y. Now you have negative 4y is equal to 36. Divide both sides by negative 4. 36 divided by negative 4 is negative 9, so your y-intercept is 0, negative 9. And then to solve for the x-intercept, set y equal to 0 and solve for x. Divide both sides by negative 12. 36 divided by negative 12 is negative 3. So the point negative 3, 0 is going to be your x-intercept. Moving on to example 2, you can use intercepts to graph an equation. Here you've got 3.5x plus 2y is equal to 14. Here they want you to label the points where the line crosses the axis. So step number 1, find the intercepts. By setting y equal to 0 and solving for x, we are solving for the x-intercept. To get x by itself, divide both sides by 3.5. So the value of x is 14 divided by 3.5. Simplifying that, you do get 4. So the x-intercept is 4, 0. Next, solve for the y-intercept. Plug 0 in for x, solve for y. In essence, you're dividing everything by 2. So the value of y is 14 divided by 2, which is 7. Next, you can plot the point that corresponds to the intercepts. Again, the x-intercept was 4, the y-intercept was 7. So we can plot the point 4, 0, and then we can plot the point 0, 7. And then make sure you connect the points by drawing a line through them, and don't forget your arrows. So here's the point 0, 7, which is your y-intercept. Again, note that crosses the y-axis. And then your second point is 4, 0. Now we're crossing the x-axis there. So now we can connect those with a nice line. Again, make sure you have arrows on both ends of your line. You can plug in whatever you want to in for x in this equation. There are no restrictions on the domain or range. So just connecting the dots. And make sure you have arrows on both ends. You can also check the graph of the equation by using a third point. When x is 2, you can solve for y and get 3.5. And then see if the ordered pair 2, 3.5 is on the line. If it's not on the line and you did your math correct, that means you plotted the intercepts incorrectly, so go back and fix those. But if you go look at this, here is 2, here is 3.5. Since the ordered pair 2, 3.5 is on the line, we can see that this graph is correct. Example 3, you can use a graph to also find the intercepts. Here they just want you to identify the x-intercept and y-intercept of the graph. Going to find the x-intercept first, and the green, note that's going to be the point -2, 0. And then looking for the y-intercept where the graph crosses the y-axis, we're at the point 0, 2. So again, to find the x-intercept, look to see where the graph crosses the x-axis. The intercept there is -2. So to find the y-intercept, look to see where the graph crosses the y-axis. And here the y-intercept is 2. Moving to the checkpoints. Here they want us to graph 2x minus 7y is equal to 14, and then label the points where the line crosses the axes. Let's find the x-intercept first. The x-intercept's at y equals 0, solve for x. The x by itself, divide both sides by 2, the value of x is 7. So now we have the point 7, 0 in the graph. To find the y-intercept, set x equals 0 and solve for y. Divide both sides by -7. So the value of y is -2. So now we've got the point 0, -2 on the y-axis. And again, you want to connect the 2 points with a with a straight line. Again, make sure you've got arrows on both ends. Connect the 2 dots, and you're done. Example 4, they just want you to identify the x-intercept and the y-intercept of the graph. At the point 0, 3, there is your y-intercept. And then for your x-intercept, we're at the point 1, 0. Moving on to section 4.4, the goal is to find the slope of a line and intercept slope as rate of change. In section 4.4, the goal is to find the slope and rate of change. So here they want you to find the slope of a line and interpret the slope as a rate of change. The slope of the vertical change, the rise, to the horizontal change, the run, between any 2 points on a non-vertical line is represented by m. The rate of change, that compares a change in one quantity to a change in another quantity. So to find the slope of the line, in words, the slope of the non-vertical line passing through the 2 points, x1, y1, and x2, y2, is the ratio of the rise, or in other words, the change in y to the run, the change in x. This is a very important formula to memorize. Your slope is given by y2 minus y1 over x2 minus x1. So again, slope is represented by rise over run, the change in y over the change in x. as a graph, you can take to any points on the line. You can calculate the rise, which is y2 minus y1, and then take the run, which is x2 minus x1, and take the rise over run, and then simplify that, and that's your slope. So we will see examples of that. In example 1, they want you to find the slope of the line shown. So in A, you've got x1 and y1 as negative 1, 2, x2, y2 as 3, 5. As you're using the slope formula each time, I greatly encourage you to write the slope. Keep the x and y coordinates in the same order in the numerator and denominator when calculating slope. This will help avoid error. So in this case, we're plugging in y2, 5 in for y2, 2 in for y1. If you have a lot of negative symbols, I greatly encourage you to use parentheses, and then x2 is 3, and your x1 is negative 1. And then just going through and simplifying, 5 minus 2 is 3. And then 3 minus the opposite of negative 1 is 4. Because taking the opposite of a negative number makes that positive. You get 3 plus 1 is equal to 4. And then simplifying that, you do get 3/4. Notice that the line rises from right to left. So this slope is going to be positive. In part B, we can choose negative 2 as y2, 4 as y1. Again, I greatly encourage you to use parentheses. And your x2 is 3. And your x1 is 1. So if you simplify those, negative 2 minus 4 is negative 6. 3 minus 1 is 2. And negative 6 divided by 2 is negative 3. Note that this line does fall from left to right. So the slope is negative. All right, for the checkpoint, they want you to find the slope of the line passing through the 2 points. So as you're doing these, I greatly encourage you to label x1, y1, and then use a formula. Again, the formula is given by m is equal to y2 minus y1 divided by x2 minus x1. So doing number 1, you're going to take y2 minus y1. So in other words, 1 minus negative 1, and then divided by negative 2 minus negative 3. Again, please use parentheses, all right, to avoid making errors, especially with lots of negative signs. 1 minus negative 1 is a positive 1. Negative 2 minus negative 3 is negative 2 plus 3. And if you simplify that, you do get 2 over 1, which is equal to 2. For number 2, y2 is negative 2. Your y1, that should read 1 over there, is 3. And that's divided by x2, which is 5 minus negative 6. Again, you simplify this. In this case, you're going to get negative 2 minus 3, which is negative 5. And then 5 minus the opposite, negative 6, is 11. So that takes care of the checkpoints. Example 2, they want you to find the slope of the line shown. So here you've got A, they made x1, y1, 2, 5, x2, y2, negative 4, 5. So using the slope formula, plug in 5 for y2, plug in 5 for y1, and then plug in negative 4 in for x2, and then 2 in for x1. Again, not a bad idea to use parentheses. If you simplify that, you get 0 divided by negative 6, which is equal to 0. The line is horizontal. So the slope in this case is 0. And then for part B, they made 3y2, which means that y1 has got to be negative 2. X2 is 4, and then x1 is also 4. And if you simplify this, 3 minus the opposite of 2 is 5. 4 minus 4 is 0. Division by 0 is undefined. So you're calculating the slope between 2 points, and the slope is undefined. The line is definitely going to be vertical. So in this case, the slope is undefined. I will show you a shortcut for the checkpoints. Here it says find the slope of the line passing through the points, then classify the line by its slope. If you see any x coordinates that are the same, you will have a vertical line. In other words, the equation x equals 1. And if that's the case, the slope will be undefined. If you see two of the same y coordinates, that means you'll have the linear equation y is equal to 7, in which case the slope will be 0. All right, moving on to the last page. Gas prices. The table shows the cost of a gallon of gas for a number of days. Find the rate of change with respect to the time. So in this case, the time is the independent variable. The price is the dependent variable. The price is depending upon the time. So the rate of change is given by the change in cost divided by the change in time. So you can choose any 2 points here. In this case, they chose the point 3, 2.09. And then we can choose a second point. We can choose the point 1, 1.99. And now we can use the slope formula. We can take 2.09 minus 1.99, and then divide that by 3 minus 1. And if we simplify that, 2.09 minus 1.99 is 0.1, and then 3 minus 1 is 2. And if we simplify that, we get 0.05. What does that represent? The rate of change in price is given by 5 cents per day. Another way you could calculate this without using the slope formula is this. Since this is a linear equation, day 1 going up to day 3 is an increase of 2. 1.99 going up to 2.09. In this case would be an increase of 0.10. Since you're taking the change in cost or the change in time, you can take the ratio of those two. If you're working the problem this way, make sure that the change in y is over the change in x. So in this case, you're taking the change in the cost, which is 0.10, divided by 2. Again, those are both positive, and if you divide those, you will get 0.05. Technically, that would be 0.05 over 1. So the cost is increasing 5 cents per gallon per 1 day. And the checkpoint, the last checkpoint for number 5, there was a slight typo with this one. The temperature should be the y value, the time should be the x value. All right, so make sure you flip-flop those. Using the shortcuts, the time increased by 2 for this one repair. The temperature increased by 5 degrees Fahrenheit over those 2 hours. So the change in degrees Fahrenheit divided by the change in the time is given by 5 over 2. And then if you simplify that, you get 2.5 degrees Fahrenheit per 1 hour as the rate of change.